Hey everybody, I want to do a quick video here, lecture on regression. And so I want to start with this, and this is a regression in Excel, and I think it's easy to manipulate the data and play with the model a little bit, and hopefully it will provide you a little more insight into how regression works and what I would expect from you for the assignment. So in this quote data set, and it's a dummy data set, I just made up these lengths and weights, but I'm comparing the length and weight of two different species. And so in the assignment that follows this video, I want you to compare some regression, so things that may be correlated, so like length and weight of fish or the length and width of tree leaves. But I want you to compare to develop a regression and a regression line or model, regression model for not just one, so not just one fish species that lives in a pond or a tree species that lives in your backyard, but compare two. So for fish, it might be a fish species that lives in two different ponds. One of the ponds might be in a really rural forested area, one might be in a more urban area, and so maybe you expect the weights of the weight and length ratio or relationship to be different. And with tree example, you might want to consider doing leaves that are shaded versus leaves that are in sunny areas to see if there's a difference. And you might hypothesize that leaves that are in shaded areas might be have a larger width per given length, so that it can try to collect more sunlight. So as I said, I made this data up, and the lengths here on the left, length 1 for species 1, weight 1 for species 1, and then length 2 for species 2, and width, or weight, sorry, for species 2. And you can see that there's this plot that I made over here, this graph, and you'll see that there are two different regression lines that are developed on there, as well as the equations. And then in the portion up here, you'll see that I have a, if I caught a fish of length 20, I sort of predict what the expected weight would be in each of the two different populations. And so this is just basically using this, this answer was given by using these equations down here. Okay, so I'm going to back up a little bit and sort of show you how I developed or how I added the plot, so that may be helpful for some folks, and then how you add the regression lines and the equation on the chart. So I'm going to copy, I'm actually going to copy all of this bit. I'm going to add another sheet. Just going to add that in. And just to try to make it look decent. All right, so that didn't actually help a whole lot. Let's see. Species 1. Let's do this. Okay. Okay, so then I want to go to Insert, and I want to insert an XY scatter plot, and just the one with just the spot, the points. I'm going to make this a little bigger so it's easier to view. And then you need to left click on it, right click on it, say select data, and you want to remove all of these things that have already been selected, so just keep selecting remove until everything is removed. And then you want to add, and the first you're going to add is species 1. And then in the X values, you're going to select the length, and I should actually make that, let me do that. So don't add the labels in the top. So length, and then the Y values, remove that, are the weights for species 1. Say OK. You want to add another, and this is going to be species 2. Species 2. The X values again are going to be the length. The Y values, remove that, are going to be the width. Say enter, and then click OK, and you can see that I now have this graph with the points plotted on there, this XY figure. I'm going to select the x-axis and go over to my axis options and change this to the minimum value of 10 and a maximum value of 20, well, 26 will do. We'll leave it there. All right, and then you need to add a regression line and the equation. So if you'll select by left-clicking on one of the points and then right-clicking, scrolling down to add trend line, and there you can see that there are different trend line options. This is a linear model, so just keep, we expect it to be linear, so just keep the linear model selected. Fish actually don't grow linearly like this, but for our sake, let's keep it this way. And then you can select down, just down here towards the bottom, select equation, display the equation on the chart. And you can see that it popped up here on the chart. This is the blue line. I'm going to select that, I'm going to bold it, and then I'm going to make it so you can see it. So made it 16, and then I'll also make it, change the color to blue. All right, and then do the same thing for the orange line. Add a trend line, display the equation on the chart, select this, highlight it all, make it 16, and let's make it orange. All right, and so you can see that I now have these equations that have been developed, and just visually speaking, you can see that the two slopes of the lines do appear to be somewhat different. There are ways to evaluate their statistical significance, if they're statistically different or not. We're not going to get into that, but then I wanted to predict, so the length of, or the width, the weight of a fish given a length. And so I wanted to use the same length for, in species 1, 20 inches, species 2, 20 inches. And the equation is simply this equation, and we know y, that is the length of the fish, and we're solving for x. I'm sorry, the other way around. We know x, we know the length of the fish, and we're solving for y. So it's simply adding in, using the equation, adding in the length of the fish here. And so this is the equation. I'll highlight it here so you can see it's equal to 1. That's really strange. It should be, these things should be exactly the same as they were previously. Let's see what happens now. I don't know why they changed. So let's see. Hang on a second, let me check on something. Okay, so this is species 1 is the blue, so we're going to change this equation to 1.0. Well, that was really interesting. 1.0313 times G2, which is this column here, and the row 2, and then 9.1511. And so you can see that the predicted weight for species 1, a fish of length 20 inches, or 20 inches or centimeters, whatever we're measuring it, would be 10.9 grams or ounces or pounds or whatever it may be. And then for the species 2, we're going to change this one as well because it seems like the equation changed slightly. So 1.379 times G3, again, the column G, row 3, minus 14.055. And you can see that it would suggest that a fish would be 13.52 grams or ounces or pounds. And I think I realize actually now why it changed, because in the previous example I made some changes to the data and not updated the equation. So anyway, that's how you do this, and look for read the assignment. If you have questions, certainly reach out. But I think this may have helped. You're going to be required to copy and paste your figure there into your discussion space, as well as report what you measured and why you expect these differences may exist. And so for, again, the contrived example here, it may be that one fish population lives in a good pond and another lives in a poor pond. And so This may be the pond that is the good pond, species 2, and I guess that should not have been species, but population 2 and versus population 1. All right, look forward to seeing you guys again soon.